Hello everybody, welcome back in this today's session. Today we are going to learn again how to find out the slopes and the deflections by the various method, and today we are going to see a specific method that we will see now. So let us first of all see what are the various methods by means of which we can find out the slopes and the deflections for the various types of the beams. So first is a double integration method. Another one is Macaulay method, third is the moment area method, fourth is conjugate beam method, and one more method we have, that is superimposition method. So out of all those, today we are going to understand what is this Macaulay method. So this method is actually a very convenient method. We can say it's a sort of a double integration as we did into the double integration method. Here specific rules are been set out by means of which we can find out the slopes and the deflections at the required point. So first point which we have to take into account is, in this method we have to take the sections between two consecutive forces or the loadings or the reactions. So there will be a number of forces. Those forces include active reactions as well as reactive reactions. There are active forces on the beam and there will be reactions offered by the supports. So all these active and reactive forces are to be treated while having the understanding of this sections. So first rule we have to follow here is that whatever sections we are going to pass, that are to be taken between the two consecutive forces. Next is where this particular method is to be utilized whenever we come across any sort of the point loads or discontinuous type of a loading. In that case this method goes very perfect. So these are the two things which we have to always follow when we are going to talk about a Macaulay method. So let us see what exactly this Macaulay methods suggest and what are the various set of rules which we have to follow for finding out the slope and deflection by the Macaulay method. So here we are going to see the procedure as well as the set of rules. So here comes the first simply supported beam which has two loads, point load W1 and W2. The span is L. The line of action of W1 and W2 are also been given. W1 is acting at a distance of A from left end support A, and W2 line of action is at a distance of B from again left support A. We know obviously there will be the reactions offered by the supports at A and B, this being a simply supported beam. So we know that first of all we have to find out the support reaction at A and B by considering the equilibrium of whole beam. So that is very much understood. Next to that, what we have to do is we have to take the sections. Now whatever rule we have seen just now, that whenever we have to pass a section, it is to be passed in between two consecutive forces or the loads. Is it okay? So first force is RA, second force is W1. So in between we have to pass a section, and after passing a section we will definitely at the same time try to understand what will be the bending moment for that particular section. So let us pass that section first, which is at a distance of X from A support. So if I want to understand what will be the bending moment here, so what we have to do, we have to consider the left hand part of the section, and whatever comes on the left hand side, all those forces moments are to be taken about this section. So here for this first section only one force is acting, that is RA. So we can take a moment of RA about section which is at a distance of X. So what will be the moment? Moment will be RA into perpendicular distance X. Is that okay? And what will be the direction? It is going to give you a positive. Why positive? There are two reasons. If I am going to consider clockwise as positive, then it is going to be plus RA into X, or if this reaction I am going to think in a way of sagging or hogging, then definitely RA is going to sag this particular as like this. Is it okay? So again sagging is positive. So here clockwise as well as sagging is positive I am treating. So what we have is moment about point first section is equal to mx is equal to Ra into x. So this is the first moment. Now what we have to do, we have to pass second section. Is it okay? But prior to that, let us see for what purpose or for what value of x this mx is going to be valid. This expression of mx, that is equal to Ra into x, is going to hold good for the value of x is equal to 0 to x is equal to a. Is it okay? Because the section is passing between a to c. So only for this portion AC this expression is true, and where the portion AC is varying from x is equal to 0 to x is equal to a. Let us take second section now. So second section again between two consecutive loading, that is W1 and W2. So this is my second section. So about this section, whatever is present on the left hand side, for all those I have to take a moment. So let us take the moment Ra into perpendicular distance x minus W1 into x minus a. So let us write that particular equation, and let us understand, if I am going to write this much total moment equation, that is the moment taken about the second section, this is going to be true when the value of x is equal to a to x is equal to b. Why? Because this CD portion is where from x is equal to a to x is equal to b. So this is true when the value of x is from a to b. Let us take the third section now. There is one more feasibility of taking the section here. I can take third section at a distance of x from point A. Now I can take a moment of all the forces which are on the left hand side. Is that okay? So Ra into perpendicular distance x, that is positive, plus Ra into x minus W1 into x minus a minus W2 into x minus b. So this is what is the equation for the moment if I take on or observe a moment about the third section. Now for what value of x this equation is valid, that is also very important to understand at this moment. So this equation is valid for which portion? First of all, d to b, and where the x value lies between what? X is equal to b to x is equal to L. So here this is what is the limit for the portion dB. Is it okay? Now it depends where exactly I want to find out the deflection or slope. If it is between the only first part somewhere here, so I have to take only first moment which is valid for the portion of AC, that is only this much term. That also we are going to see in the next point. If I have to find out the slope or deflection between C and D, or even C and D, so in that case I have to take the second section and its moment. Only that much part of a moment will be true for that particular slope and deflection between C and D. And if I have to find out the slope or deflection anywhere between D and B, so in that case I have to take the third section. Means whatever three equations we have written here, for the three sections passed in between two consecutive loadings, what is the magnitude of moment, that is the point to be understood now. So here in general we have already seen what is the generalized equation for the bending moment for all the sections. So first section Ra into x, second section extension of that minus W1 into x minus a, and if the third section I am going to take, so minus W2 x minus b is to be added to that. Is it okay? Now this is what is the generalized equation for the bending moment. Now first this particular Ra into x, where it is valid from x is equal to 0 to x is equal to a. So here we can see the value of x is getting increased as we move toward B support. Is that okay? So here when the value of x is between 0 to a, when the value of x is between 0 to a means what? Between portion AC. So in that case we have to take only first term. So only first term is to be considered. Second, if the value of x is between a to b, x is equal to a is here and x is equal to b is here. So if the value of x is equal to a to b, then we have to take first as well as second term. and when the value of x lies between B to L, from B to whole length L, then I have to consider all the three terms which are available into this particular bending moment equation. So you can say this, all the three terms are to be taken into account. So in short or straightforwardly we can say here, as I said before, if I am interested in finding out slope and deflection only for the first part AC, then only first term of mx is to be taken. If I am interested in finding out the slope and deflection between C to D, including C and D point, so in that case what I have to do, I have to take first as well as second term. But if I am interested in finding out the deflection from D to B, then I have to take all the terms available into this bending moment equation. Is that okay? So this is what is the procedure which we are going to follow again and again, and after following that particular procedure, for what just now whatever procedure we have seen, it is just for the sake of what, finding out the generalized equation of bending moment, and what are the validity of these various terms, first term, second term and third term. These are mentioned in this particular below points. Now once we understand this, what we have to do, we have to go back to the governing equation of slope and deflection, which we have already seen into the double integration. And what is that governing equation? That is the, what we can say, EI d2y by dx square, EI d2y by dx square is equal to mx, right? So this is what is the generalized equation, and that equation we are going to use onward for finding out the various slopes and the deflection at the various required points, right? Now let us see what are the various rules. As I have said that I have to do the integrations of the double integration here. So let us first of all see, when we have to use the generalized equation or governing equation of double integration, that is EI d2y by dx square is equal to mx. So there you should understand I have to integrate twice. So with the first integration, what I will be having? I will be having EI dy by dx is equal to right hand side integration. Now in this integration, whatever set of rules we shall be coming across, most of them are related to the integration procedure which we are going to follow in this particular methodology of Macaulay. Is that okay? So first rule, what we are going to say is, whenever we are going to have the integrations, so definitely we will be coming across what? The constants of integration. Now whatever constants of integration we are going to come across, that are always to be written with the first term. After first integration I will be getting what? C1. So C1 is to be written after this first term, and if I once again integrate it, so again there will be occurrence of what? C2. So that is also to be written with the first term, not at the last. Usually we write it at the last, but in this Macaulay's method, whatever constants of integration we will be coming across, that are to be always written with this first term of generalized equation of bending moment, right? So here second rule is what? Whenever we have to do the integration of these brackets, so it is always to be done as a whole bracket, x minus a square by 2. We know what is the integration of this, x minus a power plus 1 divided by power plus 1, that is n plus 1 divided by n plus 1. So here this bracket will come out to be equal to what? X minus a square by 2. So here I have shown this. If I have to integrate this, so this is to be integrated like this. Usually what we could have done, x square by 2 minus ax, but that is not true. We should not do the integration like this. Is that okay? So this is the second set of rule related to the integration which we have to follow. Third rule we are going to come across, specially only in this particular Macaulay's method, we have to take the moments of the couples. So usually we know that whenever a couple occurs in any of the beam, we never take the moments of the couple. Why? If I define moment is the turning effect, and what is couple again? Couple is also again a turning effect. Both are going to rotate that particular body about that point of observation. But in this Macaulay method, we have to take the moment of a couple. So here moment into perpendicular distance. So for example, moment is present here. Is it okay? So here what I have done, m into x minus a, right? If the couple is present here of magnitude m, then what I did, I have to take a moment of a couple. So what is magnitude of a couple? Capital M into what is perpendicular distance? X minus a, if that particular is acting here. Is it okay? So this is how we have to take the moment of a couple, and should be written like this. And when we are going to integrate this term, I have to integrate it how? X minus a raised to 1 by 1. Why? Because order or the index of this particular is equal to 0. So degree of index plus 1 divided by degree of index plus 1. So here 0 plus 1 divided by 0 plus 1. So this is how we have to do the integration when there occurs a couple. First of all, we have to take a moment of a couple, and then we have to integrate it in this particular fashion. Third rule, I hope you have understood. Next to that is related to the overhanging beam. So here for an example, if we are having a overhang on the left hand part, so there is a overhang and there is a UDL on this particular part. Is that okay? So what this rule says, whenever we are having a UDL on the right hand side, start analysis from the left hand side. So if this is what is the total beam A, C, D, B and E, then BE is a overhanging part. So we have to start integrating or taking the sections from left hand side. Is that okay? If the overhanging part is on the left hand side, then obviously we have to start from the extreme opposite end. That means from B to E, I have to start taking the section and then repeat that particular procedure. So these are the various rules which we have to follow, and once we have to follow these rules, then definitely we will be getting the solution by the Macaulay's method. So I hope all the rules and regulations are very much clear to you all. So let us see now what is to be done further. So here I have a generalized equation of a bending moment, right? Now this bending moment equation is to be substituted in what? In the governing equation, what we have already seen in the double integration. So what it says, EI d2y by dx square is equal to m. So here this is the generalized equation mx, right? So put the value of mx here. So this is the bending moment of all the sections, first section, second section and the third section. So I have substituted the value of mx. Now what we have to do in order to find out a slope from this governing equation, I have to integrate once. So if I integrate once, what I will be getting? EI dy by dx is equal to RA x square by 2 plus C1. So this is the first constant of integration which I have written with the first term. Now what is remaining? Second and third. So minus W1 into x minus a whole square by 2 minus W2 x minus b whole square by 2. So this is how I did the integration, and I have stick up with the various set of rules which we have already seen in the earlier slide. Is that okay? So constant occurred here. I have seen second rule, that bracket is to be integrated as a whole. So x minus a was there. So I have integrated bracket whole square by 2. So just follow the next step. What it is? It is to do the integration once again so as to get a deflection. So if I do the integration once again, EI y is equal to RA into x cube by 6 plus C1 x plus C2. So again second constant of integration I have written with the first term minus W1 x minus a whole cube by 6 minus W2 x minus a whole cube by 6. So here I came across two equations, equation number small a and small b. So these two are the equations which are to be utilized further, but these equations a and b will be useful when we are going to find out the value of C1 and C2. And for finding out the value of C1 and C2, there are certain methods by means of which we can find out the constants of integration in the structural mechanics. So we will see that one by one in the coming slide. So here this is what is the total procedure which we have to adopt in this particular Macaulay method. I hope you all have understood what is the standard procedure, what are the various sets of rules, and how they are to be utilized in finding out the slope and deflection by the Macaulay method. So I hope you have understood this. Let us move ahead and try to understand how these values of C1 and C2 are to be found out. So here we are coming across certain methods by means of which we can find out the constants of the integration. So the first method is boundary conditions, second is continuity conditions, and the third one is the symmetrical condition. Is that okay? So these are the three various methods by means of which we are going to find out the constants of integration. Let us see one by one now. So here comes first boundary condition method by means of which we can find out the value of C1 and C2. So this is what is a simply supported beam supported at A and B. Is that okay? Let us find out what are the boundary condition for this and for what purpose we are trying to understand the boundary condition. All the boundary conditions are to be understood with respect to only the slopes and the deflection. Is that okay? So here let us see where is the slope, where is the deflection, where it is maximum, where it is minimum. So let us see that. So in order to understand that, what I have to do is I have to first of all draw a elastic curve of a bend beam. So after loading it is going to bend like this, and after that what is going to happen? We are able to understand where there is a slope and where there is a deflection. Is that okay? So here at point A it has not been displaced, means there is no any deflection of point A. Even at point B there is no any deflection. Is that okay? Now as far as the slope is concerned, how do we understand a slope? Whatever elastic curve we have, wherever we have a maximum elastic curve, there we have to draw a tangent. So inclination of that tangent is called as what? It is called as a slope. Is that okay? So this is what is a slope. So here about which point I am finding out this? I am finding out about point A. So this is slope dy by dx at point A. It can be also called as IA. I is designated for the slope. Is that okay? As far as the deflection is concerned, here you can see once again I have to draw a tangent to the maximum curvature. So here what is happening? This tangent is almost horizontal or parallel to the axis of a beam. Is that okay? So slope is 0 here. All of you are getting now? So from these two you can understand what is the deflection at A, what is the deflection at B, what is the slope at A, and what is the slope at this particular center where there is a another curvature or the maximum curvature we can have at this particular center. Is that okay? So let us talk in terms of the value of distances, that is with respect to x. X is equal to 0 at A and x is equal to L at B. Is that okay? So if we think on when x is equal to 0, when x is equal to 0 means at point A, how much is deflection? Deflection is 0. At x is equal to 0, how much is the slope? Slope is maximum. And where there is a minimum slope of 0? Minimum slope is available here, that is 0 slope. So here maximum slope is at point A. So let us enumerate in terms of those various limits. So at x is equal to 0, y is equal to 0. You can see here at x is equal to 0, y is equal to 0. And how much is slope? It is maximum. That also can be found out. But okay, you can see here at x is equal to L by 2, center deflection is maximum. At x is equal to L means at point B, how much is the deflection? 0. So at x is equal to 0 and at x is equal to B, where there are supports, there the deflections are 0, minimum 0, right? And how about maximum deflection? Maximum deflection shall be occurring where there is a minimum slope, that is slope is equal to 0. Is it okay? So where slope is equal to 0, we get maximum deflection. So here we can say at x is equal to L by 2, deflection is maximum, and at x is equal to 0, slope is maximum. So at x is equal to 0, slope is maximum, minimum slope is here. So these are the boundary conditions which are to be utilized for finding out the constants of integration C1 value and C2 value. Is that okay? This was related to a simply supported beam. So whenever it comes to a simply supported beam, always remember at the support at x is equal to 0 and at x is equal to L, there is 0 deflection. But at x is equal to 0 and at x is equal to L, definitely we will be getting the maximum slope, right? So at x is equal to 0 and y is equal to 0, we get maximum slope, right? And at x is equal to L by 2, we will be getting maximum deflection. So this is what is the set of boundary conditions for the simply supported beam. Let us talk about the cantilever beam now. So this is what we have, a cantilever beam. Here you can see a elastic curve due to the application of load, it has bent into this particular fashion. Again in terms of x, if I am going to find out, so x is equal to 0 and x is equal to L. So you can see here at a distance x from free end, I am going to take a section, right? So x goes on increasing towards left, here x went on increasing towards right. So this is what is the second thing which we have to understand, where we have to take the sections in this particular simply supported beam and in this particular cantilever beam. Now here I have understood at a distance of x I am going to take a section, and let us understand now when x is equal to 0 and x is equal to L, what is slope and what we can say deflections. So here you can see at x is equal to 0, y is equal to 0. So here I am actually going to find out a distance x from here, right? So when x is equal to 0, deflection is 0. When x is equal to 0, slope is 0. Here we can see there is a maximum curvature here, I can draw a tangent. So maximum slope will be available at this free end. So here first condition we have understood, when I am going to count x from left to right, when x is equal to 0, y is equal to 0. If I am going to find out x from right hand side toward the left, if this is what is x, when x is equal to 0, there will be maximum slope and deflection. When x is equal to L, there will be 0 deflection and 0 slope. Either way, either this x or this x, you should be able to understand the boundary condition. Only one thing we have to understand, whenever we have an elastic curve, whether you measure x from this end or this end, just pay attention on the elastic curve. So here you can see this is what is a maximum deflection. Is it okay? Now here we have a maximum deflection, this is the maximum curvature, from here I have to draw a tangent, so this will be maximum slope. So whether you measure x from this end or that end, just we have to understand these two conditions. Is it okay? So here as I am going to measure x from left hand side, so at x is equal to 0, deflection is 0, and when x is equal to 0, slope is also 0. Here you can see I have shown a tangent, so this is what is given as the maximum slope. So maximum slope is where, when x is equal to L, means from here to here value of span is equal to L, there will be maximum deflection. Is it okay? So here this is another boundary condition for the cantilever type of a beam. I hope you have understood. It is a matter of understanding from which end you are going to measure that particular distance. If x from this end, so this is what is the thing. If I measure x from this B towards A, so in that case things will be reversed. So this is how we have to find out the boundary condition, and after selecting this condition, standard condition, whether it is a simply supported beam or a cantilever beam, accordingly you are going to take your boundary conditions and put it in equation number small a and small b in the earlier slide. You will be able to find out the value of C1 and C2 by which method? By the boundary condition method. Second method is the continuity conditions. Is it okay? Now here this is what is again a simply supported beam, and I am interested in finding out the slope and deflection about point C. Now whether you start working from left to right or right to left, all of you getting, if in first condition what I will do, I will find out the slope and deflection from this end up to C. In second case what I will do, from this to this I will find out the slope and the deflection about point C. It is going to be one and the same. Why? Because this deflected part is has its continuity on the B support, or till B point it is continuous. So it is possible to find out the deflection at this C point from left hand side part, whatever magnitude we will be having, that is same from the right hand side part. So it says deflection at C determined from the left hand part shall be always equal to the deflection at C which is been found out from the right hand side part. Similarly for the slope, slope at C from left hand side is equal to slope at C from the right hand side. Why? Because there is a continuity of this particular elastic curve beyond point C towards right as well as towards left. So it doesn't matter whether you start from left or right, you will be definitely getting the same magnitude of slope and deflection at this particular point C. So here you can see we have gone through the boundary condition. We have also tried to understand what is the continuity, because here it has been said that continuity of a deflected curve at point C, it is beyond C. Is it okay? If I am going to come from this to C and if I go beyond C, so it is continuous. Same happens from when I move from right to left. Can you see this continuity beyond this C point on the left hand side support? So this is the advantage. We are able to find out the slopes and deflection about point C from left hand side part also as well as from the right hand side part, and both magnitude will be one and the same. So here whatever first method boundary condition and second method, usually these two methods, boundary condition and continuity conditions, are more than sufficient to find out the value of C in this Macaulay's method. Third is symmetry. So here you can understand about the symmetry. If I have to find out the deflection here, so that will be delta C, which is at a distance of x. Is it okay? Now there is one more point here D, which is again at a distance of x from A, right? So this is x up to point C, up to point D it is again x. First of all what I will do, I will find out the deflection at point C from this particular end. So that is equal to delta C. There is one more point here which is at a distance of x from point A. So directly I can say, as there is a symmetry in this, so delta C will be equal to what? Delta D. Here I am going to take the advantage of the symmetry of this particular thing. Is it okay? That symmetry is with respect to the moment of inertia, basic parameter of the beam, as well as the type of loading, as well as the supports. Is it okay? This is simple support, this is also simple support. Here moment of inertia of this particular beam is throughout same, the distances xx are same. So if I cut this beam at the center, you will be getting a mirror image. So here from the advantage of symmetry of this particular beam, I am able to find out the reflection at C, which will be the deflection at D, which is at a distance of x from the left hand part. So this is how we have to apply the various conditions for finding out the values of integration constant C1 and C2. As I said earlier, that first and second are more than enough to find out the values of constants of integration C1 and C2. So this is what is the basic, what is very much necessary for thoroughly understanding the Macaulay method. I hope you have understood well the various concept of this. You have understood the governing equation of slope and deflection, that is EI d2y by dx square is equal to mx. You have also understood how the bending moment is to be found out for the various sections, and what term is valid for what value of x also we have tried to understand out of this. And after putting all these values, that is EI d2y by dx square is equal to mx, right hand side mx is the generalized equation for the bending moment. After getting this total set of equation, what we are going to do? We are going to integrate twice. So with the first integration, I will be getting what? Slope dy by dx with the first constant C1. Once again I will integrate that particular equation, so I will be getting EI y is equal to first term plus C1x plus C2. So this is how we have to do the integration twice. So as we are doing the integration twice, so we will be having two constants C1 and C2, and by applying the knowledge of these various conditions, that is boundary condition and continuity conditions, we will be able to find out the value of C1 and C2. And once we find out the value of C1 and C2, substitute into the equation of slope and deflection. What we have to do? We have to substitute the value of C1 and C2, and after substituting that, whatever new equation we will be getting, those equations are called as generalized equations for finding out slopes and deflection at any distance x is equal to 0 to x is equal to L. In between 0 to L, select any point, take that particular equation, put that value of x, and then you will be able to find out the slope and deflection on that particular required beam at the required point. So this is what is the procedure which we are going to follow for each and every type of a problem. So remember all those sets of rules, just stick up to those. You have understood what are the various boundary conditions and the continuity condition. In most of the cases, to be very precise, even I will not be taking this second and third method, that is continuity condition and the symmetrical condition for finding out the value of C1 and C2. Only the first method, that is boundary condition method, is more than sufficient to find out the value of C1 and C2. And once we find out that, rest of the thing is just putting the value where the required slope and deflection is required, put that value of x and get the value of slope and deflection. So this is what is the Macaulay's method. I hope you have understood. If you come across any sort of a query, definitely post it in my chat box. I will try to answer those particular queries.